semiconductor which is based on transistor. In this topic, we are going to discuss about transistor types and its working and principles. So let us start with transistor. Why it is known as transistor? Transistor built with these two words. One is transfer and another one is resistor. That means here input to output, your resistance will be transferred. That's why it is known as transfer plus resistance and becomes transistor. So let us discuss about its types. Transistors are divided into two types. Number one is BJT, which is known as bipolar junction transistor, and number two is UJT, which is divided into unipolar junction transistor. BJT has two types. Number one is NPN and number two is PNP. Similarly here, UJT is divided into two types. Number one is FET and number two is MOSFET. So in today's topic, we are only discussing about BJT, bipolar junction transistor. So let us discuss about BJT. So as per its name, bipolar junction transistor, here we are going to use two carrier charges. One is majority carrier charges and another one is minority carrier charges. So due to this, it is known as bipolar junction transistor. So majority carrier charges may be electron or holes. Similarly here, minority carrier charges may be electrons or hole. It depends on its types, like NPN or PNP. So that means we are going to use holes and electrons in this diagram. So BJT types and its introduction. Here BJT are divided into two types, NPN, number two is PNP. That means we have seen in diode there are two types of material, P type and N type, so we are connecting two terminals. But here there are three types of material, N type, P type and again N type. Basically we are doing chemical process and combine these three materials together. So due to this chemical process, there will be two different types of junction is created. And due to this, we have to connect three different types of terminals, which is called as emitter, collector and base. Whereas base is center terminal and collector and emitter end terminals. Now here we can see BJT, that means bipolar junction transistor. Bipolar, that means holes and electrons both are involved in current flow. And junction, there are two types of junctions, emitter base junction and collector base junction, or we can say J1 and J2. So this is the introduction of BJT and its types. Now let us discuss about NPN transistor. Particular here we are discussing NPN material. That means two N-type material is built at the end of terminal, and between this two type material we can put P-type material. That means sandwich. P-type material becomes sandwich between the N-type material. BJT is three terminal device. BJT is semiconductor device constructed with three doped regions, N-type, P-type and again N-type. Here we can see this is the symbol of NPN transistor. So we can see in this symbol there are three terminals. First above most collector terminal, then base, and below we can see emitter. So this is the symbol of BJT. Now here we can see this is the construction of NPN transistor. As I said that P-type material is sandwiched between N-type material. emitter terminal, base terminal and collector terminal. Now here we can see emitter is highly doped material in this NPN transistor and collector is lightly doped material than emitter, but base is very thin and narrow region compared to the emitter and collector. That means, in short, I can say emitter has more number of electrons than collector. Collector has more space than emitter and base, and base is less space and less carrier charges. We can say in n-type material there are number of electrons which are majority carrier charges and minority carrier charges are holes, whereas in base there are majority carrier charges are holes and minority carrier charges are electrons. Similarly here in collector there are majority carrier charges are electrons and minority carrier charges are holes. So these are the construction of NPN transistor. Now PNP transistor, this is the symbol of PNP transistor. Here we can see arrow indication is inward direction. So remember this, if arrow is going inside, that means it is PNP transistor. If arrow is coming outside like this, so it means it is NPN transistor. In short, you have to remind that wherever the arrow, you can type here N type. Okay, so here we can see N, then after P and thereafter N. That means NPN symbol. And here in this case, arrow is inward side, so we have to put N at the base terminal, so it becomes PNP. And remember this thing, arrow should be always at emitter terminal. So this is the symbol of PNP transistor. Here we can see this is the construction of PNP, but here N-type material is sandwiched in between P-type material. So it becomes PNP transistor. Now NPN and PNP transistor diode analogy. Here we can see first essentially from two back-to-back PN junction of the same block of semiconductor material. So here in case number 1, in figure number 1, we can see the symbol of NPN and PNP. Now, how we can make this transistor with the help of diode? So we have to put back-to-back diode in this form. If there is an NPN, so diode is opposite direction in this manner. So it becomes NPN. In this symbol, this is the PNP. Diode is in direction, same direction, so it means PNP. So here we can see this is the NPN and PNP. Now diode analogy. Here we can see this is the NPN first. Consider this one. NPN, emitter, base and then collector. Now diode's last terminal is P, then N and then P. So it becomes PNP. Here we can see this is the diode analogy of this transistor. How we can make transistor with the help of two diodes. This is the instruction for that. Now NPN and PNP transistor. Here we can see electrons are majority carrier charges and holes are the minority carrier charges. Right? So in NPN, majority carrier charges are electron. Here we can see minus sign. That means it indicates electrons, and plus sign it indicates holes. So emitter, base and collector. So we can say this is the unbiased condition of NPN transistor. So basically transistors are NPN and PNP in unbiased condition. It is look like this. In PNP, there are majority carrier charges are holes and minority carrier charges are electrons. Now, this is the unbiased NPN transistor. This is the NPN transistor. We already studied in PN junction diode. Whenever it is in unbiased condition, that means there is no DC supply, there is no connection of battery. So at this time, depletion region is created, as we discussed in PN junction diode. But here there are two junctions. Here we can see this is the depletion region between emitter to base junction, and here this side we can see collector to base junction depletion region. Number of electrons, ions are more inside the p-type material, or we can say inside the base terminal, because there are minority carrier charges are electrons. Here we can see from this construction of NPN transistor. After this depletion region built, no current can flow from one type material to another type material, because due to depletion region, it is also known as barrier, because it stops the flow of electrons. So here we can see, if we have to flow current, if we have to push this electron, then we have to connect with battery. That means DC supply. So it becomes biasing. Here we can see biasing of NPN transistor. In this NPN transistor, there are three different types of terminal. So we have to put two different types of batteries, because of two junctions are created. Due to two junctions are created, two batteries need to connect in this construction. Two battery, that means we have to study about four different types of operations, because there are two biasing. One is forward bias and another one is reverse bias. That's why we have to see four probability: forward forward, forward reverse, reverse forward, reverse reverse. Here we can see region of operation. If base emitter junction is in connected reverse bias and collector base junction is connected in reverse bias, both are reverse, that means the region is known as cutoff region. Its application is open switch. If base emitter junction is forward bias and collector base junction is reverse bias, that means it works in forward active region, and its application is amplification. If base emitter junction is forward bias and collector base junction is forward bias, then it becomes saturation region, and its application is closed switch. And last, if both the junction, DE junction is in reverse bias and collector base junction in forward bias, so it becomes reverse active region. It is used in digital. So in this chapter we are discussing about only three regions: cutoff region, active region, which is here forward active region, and saturation region. Here we can see the transistor as an amplifier. If in order to use transistor as an amplifier, it should be operated in active region. So let us connect it in active region. Here, working of NPN transistor, emitter base junction must be forward bias, collector base junction must be in reverse bias. The base region is very thin and lightly doped. Most of the current carries injected. Here we can see this is the construction with biasing of NPN transistor. We have to connect like this NPN transistor in forward bias and in reverse bias. Here we can see VEB, which is connected in forward bias. Here we can see VCB, which is connected in reverse bias. Why it becomes forward and reverse? Here we can see N-type material, which is connected to the negative NN. So both are similar, N-type and N, that means negative. That means it is in forward bias. Here we can see VCB, positive terminal of battery is connected to the N-type. Now that is N-type, and here P, positives P. So both are dissimilar, that means it is connected in reverse bias. So here the collector region is moderately doped and is largest of these three regions because number of electrons are gathered in collector terminal. So after all, equation will be IE is equal to IB plus IC. Here we can see IE, that means the emitter current, is equal to base current plus collector current, because number of electrons flowing from emitter side to enter into base side and goes to the collector side. So here we can see working principle of NPN transistor. Here in this emitter terminal, number of electrons are which are moving towards base terminal like this. Here that electron is recombined with holes in base terminal and few electrons are entered, or we can say injected, in the collector side. Now that electrons which are recombined with holes, that electron flows downward direction. Now here we can see this is the arrow for IE. Now that electrons flow downward side, that becomes IB. So this is the base current, and that electrons which is injected into the collector side is known as IC, which is known as collector current. Collector current is 98% of total current, whereas base current is only 2% of total current. That's why IE is equal to IB plus IC. Now here we can see working principle of PNP transistor. Similarly, emitter majority charge carriers, holes will be emitted, base few hole electron pair will be created, remaining holes will be collected by collector side. Here we can see this is the construction of PNP transistor. Now let's recap of today's topic. Here we have seen in this lecture bipolar junction transistor. This is known as BJT, which is created like NPN and that PNP type. Here in this NPN, P type is sandwiched between the two N type material, and there we can say in red P type material. In between P type material there is N type material. So here we can see this is the NPN and PNP transistor. That's why it is known as bipolar junction transistor. Here we can see the flow of electron always flow from emitter to collector side. So this is the flow of electrons, emitter to collector side, and here we can see this is the symbol of BJT, in which more specific NPN and PNP transistor, which has three terminals: collector, base and emitter. Now, how can we identify PNP or NPN transistor? With the help of this arrow. If downward direction arrow, that shows it is NPN, and inward direction arrow, it shows PNP. So this is the bipolar junction transistor as we discussed in today's lecture. This is the most important, and its applications are in digital electronics or in analog electronics like an amplifier and many more, transmitter and receiver. So this is the recap of today's topic. Now, advantages and application of transistors. So first, very small size and less weight, low operating voltages. Here we can see lower cost, higher efficiency, very low sensitivity, very long life, and applications as a switch and as an amplifier. So that's all for today's lecture. I hope you can understand easily about transistor and its types. Thank you.